We will now derive exponential function, the derivative of exponential function. Again, we will recall that if y is equal to a to the x, then the equivalent relation is x equals logarithm of y base a. So we will just use implicit differentiation. So the derivative of x with respect to x is 1. And the derivative of logarithmic function, if you try to recall, okay, the derivative of logarithm of u base a is equals to 1 over u ln a multiplied by the derivative of u with respect to x. So here we can use that formula. So the answer is 1. Instead of u, it is y. And then we have here ln a. This copy everything. And derivative of y with respect to x, of course, is you can just write here y prime. And then we can simply cross multiply. So y ln a is equals to y prime. And there we have it. Y prime equals y ln a. But originally, y equals a to the x. So y prime equals a to the x ln a. Now, if a equals to e, then we have this is derivative of this is a to the x, right? Then the derivative of e to the x equals e to the x. And then because we have a is e, ln e is equals to 1, so it is e to the x. So this is the only function whose derivative is the same as the function itself. And to generalize the formula, if u is a function of x, then again by the chain rule, the derivative of a to the u is equals to a to the u ln a du dx. And the derivative of e to the u equals e to the u du dx. Okay. So this is the last set. This is the last set of the formulas. Okay. So we will recall the derivative of ln u equals 1 over u times du dx. So this completes the derivative of logarithmic and exponential function. So we memorize this formula, derivative of u, ln u, a to u, and e to the u. I will give you an example. Suppose that we have y is equal to, of course, we calculate dy dx. So one example is ln x squared plus 1. So if y equals ln x squared plus 1, so y prime equals, according to the formula, ln u, so 1 over u, so we just copy everything, times the derivative of u. So the derivative of x squared is 2x. So you can just write this as 2x over x squared plus 1. Remember, this du over dx can always be placed in the numerator. Another example, let's say y equals logarithm of x to the 6 power base 3. So you can rewrite this as 6 times the logarithm of x base 3. So that y prime is 6 times the derivative of logarithm of x base 3 is 1 over x ln 3. So this is simply equal to 6 over x ln 3. Okay. Now in logarithm, we usually write logarithm of product or power as simpler logarithms. Let's take another example. Suppose we have y equals ln x square root of s squared plus 1. course, if you use the logarithmic formula, 1 over u, and then you end up with the derivative of product. To avoid that, we will first rewrite y as ln of x plus ln of square root of x squared plus 1. So we apply the formula logarithm of m times n equals ln m plus ln n. Natural logarithm of m plus natural logarithm of n. And so y equals ln x plus, take note that this is x squared plus 1 raised to 1/2. And again, we will use property number 4. So ln x, so 1/2 can be placed in front. So 1/2 ln x squared plus 1. And this is now the time to calculate the derivative. So this is the derivative of x is 1 over x plus 1/2. Now the derivative of x squared will be placed in the numerator, 2x, and just copy x squared plus 1. 2 over 2 cancels out, so the answer is 1 over x plus 2 divided by x squared plus 1. Okay. Okay, so logarithmic differentiation. Logarithmic differentiation is used to calculate the derivative of y, let's say, equals to u raised to v. So where both u and v are variables, let's say none of which is a constant. So here we simply write the following. The first step is to take the natural logarithm of both sides. So we have here ln y equals ln u raised to v. And v is a power, so this will be v times ln u. And then we'll just apply implicit differentiation. So the derivative of ln y is 1 over y times y prime equals, so we use product rule here. So v times the derivative of ln u is 1 over u times derivative of u with respect to x. And then plus ln u times derivative of v with respect to x. And finally, we can now calculate y prime. So y prime equals y multiplied by v over u times the derivative of u with respect to x plus ln u times the derivative of v with respect to x. And you just copy the original value of y. So this is uv times v over u times du dx plus ln u times dv dx. So you don't have to memorize this formula. All you have to do is memorize this technique. Okay. A new technique in differentiation, it is called logarithmic differentiation because you start by taking first the logarithm of both sides of the function. Now, this can also be used if y is, let's say, u, v times u to the n power over w, etc., etc. So, meaning it involves product and quotient and power of too many functions. So, you always start by taking the natural logarithm of both sides. Okay? So just to give you a few examples, so let's calculate y prime. Number 1, we have y is equals to, let's say, sine x to the power x. So we start by taking ln of both sides. And so we will have here ln y equals ln sine x to the power x. And we know that x can be placed in front, so ln sine x is ln1. And then we now use implicit differentiation. So this will be y prime over y. So this is the same as 1 over y times y prime is equals to a product rule x times 1 over sine x times the derivative of sine x is cosine x. Then plus ln sine x times the derivative of x is 1. So y prime is equals to y times x cotangent x, because cosine over sine is cotangent, plus ln sine x. And then finally, you just copy the original value of y. So sine x to the x power x cotangent x plus ln sine x. So that is the value of y prime. Okay? Okay, so here we have another example. It involves a lot of product, quotient, and power. So again, we will take ln of both sides. So we have ln y is equals to ln e to the x sine x over x square root of x squared plus 1. And we have logarithm of quotient is difference of log. So this is ln e to the x times sine x minus ln x square root of x squared plus 1. So ln y is equal to, we know that ln of product is sum of logarithms. So this is ln e to the x plus ln sine x. This is also ln of x plus ln square root of x squared plus 1. So ln x, ln square root of x squared plus 1. This is actually equal to x squared plus 1 raised to 1 half. Okay. So here we can place x in front and we have ln e. ln e is 1. And this is ln sine x minus ln x minus, this is raised to 1 half, so 1 half ln x squared plus 1. So that is ln 1. And then we can use implicit differentiation to come up with y prime over y is equals to the derivative of x is 1, derivative of sine x is 1 over sine x times the derivative of sine x is cosine x. Derivative of ln x is 1 over x, and then derivative of x squared, so you have 2x over x squared plus 1, because derivative of ln u is derivative of u over u, so the derivative of x squared is 2x. So we can cancel this, and don't forget to cross multiply y 1 plus cotangent x minus 1 over x minus x over x squared plus 1. And then you just copy y, or you can just write here where y is equal to e to the x sine x divided by x square root of x squared plus 1. Okay? Any questions? So that's all about logarithmic differentiation. For exponential functions naman, okay, let's compute y prime if y equals 2 to the x. No? So we can easily see that y prime, so the formula is derivative of a to the u equals a to the u times ln a times du dx. And the derivative of e to the u equals e to the u times the derivative of u with respect to x. So this is the formula that we are going to use. So y prime is just equals to, still it will be 2 to the x then ln 2 times du dx. And the derivative of x is just equals to 1. So no need to write that. Okay. Number 2, y equals 5 raised to sine x. So y prime is 5 raised to sine x. And then times ln 5. And then derivative of sine x is cosine x. So y, another example is y equals x e to the 3x. So y prime is, so we have to use product rule. X times the derivative of e to the u is e to the u du. So this will be 3e to the 3x times the derivative of 3x is 3 plus e to the 3x times 1. So the answer is 3x e to the 3x plus e to the 3x. You can factor out e to the 3x and you will have 3x plus 1 for your y prime. So remember that this formula implies that if you are taking the derivative of, let's say, any constant times x with respect to x, so the answer is k e to the kx. So parang shortcut. So pwede mo ilagay kagad dun yung 3. Okay. And that's how easy is it to calculate derivative of exponential function. And last, for example, you are asked to find the derivative of e to the negative 2x cosine 6x. So you will have y prime equals, okay, first times the derivative of the second, e to the negative 2x, derivative of the second is negative sine 6x times the derivative of 6x is 6 plus cosine 6x times derivative of e to the negative 2x is matic, no? Negative 2, so negative 2 into negative 2x. So in exponential function, the derivative of exponential function, you always have the exponential function in the derivative. So hindi na bago. Kung meron mo ganito, meron mo ganito sa kanyang derivative mo. Okay. So you have to remember that. We just simplify 6 times negative 1, so negative 6 e to the negative 2x sine 6x, and this will be negative 2 e to the negative 2x cosine 6x. You can factor out e to the negative 2x, and this will be equal to 3 sine 6x plus cosine 6x. So that is all about derivative of exponential function. So remember that if we are going to evaluate derivative of very complicated functions, so remember this, no? It involves product. Wala na. Napura ko na pala. Okay, so just remember this formulas here. Okay. Derivative of logarithm of u, then derivative of exponential function, and then you can go back to the derivative of logarithmic differentiation. Okay.